Okay, so our factoring formulas now. We just had minus, right? We just did x cubed minus y cubed. Well, you can also do it with plus. And here's the formula. So the reason why I brought this up to you with the formulas is, see how this is plus x cubed plus y cubed, and you start with x plus y? Well, if you look back on what we just did with that formula, right? This was x cubed minus y cubed, and you started with x minus y. So the point is, whichever one it is what you start with. If it's minus, it's x minus y. If it's plus, it's x plus y. So it's just something for you to keep in mind when you're doing this. Next up is, if this is plus, then this is minus, right? If you look back on this one, just trying to help you remember these formulas here. This one was minus, so this was plus. So just keep that in mind when you're doing these formulas. And the y squared is always positive. So the reason why I'm telling you this is because this is positive, because it is cubed, it's x plus y. And then since this is plus, this is minus. And if this was minus, this was plus. That's what I'm trying to explain to you with those formulas. So I take a look at this. Is there something cubed that would give me 64? There is. 4 cubed. Is there something cubed that will give you 125? Yes, there is. 5 cubed will give you that. So now that we have our cubes, and now that I know that we can do something cubed, I will group those. That's a 4x cubed and a 5y cubed. So according to the formula, I take the first item and the second item and I just add them together. So that is a 4x plus 5y. And that's what goes in these items to start. Then you take the first item and you square it. Well, that's a 4x, so 4x squared. Now it's minus, right? Because if it's plus here, it's minus here. So it's minus the first term times the second term. And then it's always the last term squared with an addition sign. So now the first term is the first term. So I need to take that squared through. 4 squared is 16, so it's 16x squared. 4 times 5 is 20, but it's a negative, so it's negative 20, and the x and y don't go together because they don't go together, right? They aren't the same variable, so I can't combine them. I just write them side by side. And this is 5 squared, which is a positive 25, and it's a y squared as well. And there is your formula factor. So let's have some more examples here. Can you rewrite this since we're talking squareds? See how that's a squared? Can I rewrite 25 as something squared? Yes. That becomes 5 squared. Can I rewrite 49 as something squared? Yes, that's 7 squared. So when I group those together, it's a 5r squared minus a 7s squared. So 5r is the first term, 7s is the second term. So because these are differences of squares, I take the first term minus the second term, and the first term plus the second term. That's all I'm doing. That's the difference of squares. And there's your answer. The next one is to the fourth. Now I know you're sitting there saying, whoa, 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 we didn't do any to the fourth power. You're right, we didn't. But can I rewrite them as something squared? And the answer is yes. Can you rewrite 81 as something squared? You betcha. We can rewrite that as 9 squared. This x to the fourth, I can rewrite that over here as x squared squared, right? What is squared squared? Well, that means you multiply them, and 2 times 2 is 4. So I actually can rewrite x to the fourth as x squared squared. So this y to the fourth, I can rewrite that as a squared squared. And we just said that 81 I can rewrite as 9 squared. So just like before in this problem, I'm going to take my two terms and put them together. So I have a 9 squared and an x squared squared. I'm going to take those two and put them together to get a 9x squared and a y squared as my second term. So now according to difference of squares, right? According to difference of squares, you take the first term minus the second term. So here's my first term, and there's my second term. First term minus my second term, and my first term plus my second term. So there you go. Except we aren't done yet. And the reason why we aren't done is, do we have any more differences of squares? And the answer is yes, we do. Okay? This isn't a difference of square. This isn't because there's an addition sign there. So this is the only one I can look at as being a difference of squares because it has a minus sign. And the answer is yes, it is. Because how can you rewrite 9 as something squared? You can rewrite 9 as something squared as a 3 squared. So this will become a 3x minus y and a 3x plus y is the point I'm getting at. And this just stays the same. So the reason why these get really tricky are you can sometimes do the difference of squares 2, 3, maybe even 4 times, depending on what the exponent is. Okay, so keep that in mind when you're doing some of these problems. This one, I know it looks crazy, but can you rewrite this, because this is squared, right? Can you rewrite this as something squared? You got it, you can, right? We just went over x to the fourth, you can rewrite as x squared, squared. And 16, you can rewrite that as a 4 squared. So I have to combine these into one term. So to do that, I get a 4x squared, squared, and this is still squared. Now I know that you're looking at that going, why minus 2z? Well, it's all in parentheses. According to your rule, you take the first term, which is all in the parentheses, minus the second term, which is all in parentheses. This is all in parentheses, meaning this is all your first term. So, your second term. So it's this minus this, because it's your second term. So there's your first term, right? There's your first term. This whole thing is your second term. So it's minus all of that stuff and plus all that stuff. Well, minus, that means I have to take that through. So you actually end up with a 4x squared minus y plus 2z, and that's addition, so you don't take it through, so that's 4x squared plus y minus 2z, and there are your factors.
Tina, you fat lard, come get.
Okay, so on to the examples with cubes, right? So on to our examples here with cubes. So let's take a look here. And what we have is, can you rewrite the first term as something cubed? That is a yes, you can. A cubed. Can I rewrite 64 as something cubed? Yes, that's a 4. So that is a 4b cubed. So according to our formula, since it's addition, you take the first term plus the second term. So a plus 4b. Then you take the first term and you square it, which is just an a squared. Because it's addition, you just take those two terms and multiply them together, which is 4ab. And because it's addition, right? If it's addition, this is subtraction. That's why I put a subtraction there. And then this is always addition, and it's the last term squared. So it's plus a 4b squared. So I need to take that squared through. So this is a minus a times 4 times b is minus 4ab. And this squared through, so that is a 16b squared. So it's plus 16b squared. And there's your answer. So when we come back here, we're going to have a couple more examples using the factoring formulas, but I don't want to try to cram in too much at one time here. So when we come back, we'll try to finish the sum and difference examples in prereq 6 on factoring.